Hi everybody. So this is lesson 3 and it's about objects that are either being thrown up into the air or being dropped down from a height. Okay, so we can either throw something up or you can throw something down, in other words. So that's what we're looking at. So when you throw something up into the air, like this ball that's being thrown up and then it comes down, the moment it leaves your hand, the only force that is acting on it is the force of gravity. And that is why your initial speed might be quite a lot, but as it goes up, because gravity is pulling it down all the time, its speed keeps reducing and it becomes zero at the top. And at the top, it stops momentarily and then its speed starts increasing on its way down. Now we know that this force of gravity is, we used 10 newtons per kilogram last year, but this year we're being a little more precise. In year 12, we use the force of gravity for every kilogram of mass as 9.8 newtons per kilogram. So the acceleration due to gravity is 9.8 meters per second squared. Now this diagram is to do with the velocity. So the other thing is, for anything that's going in the air, if you ignore air resistance, at any horizontal height, the size of the velocity is the same. The only thing is that the direction's opposite. So when you're throwing it up, velocity is upwards. When it's falling down, the velocity is downwards. Okay, and I've drawn a smaller arrow here because the velocity there is decreasing. It's small. So the velocity at any horizontal level is the same, but the direction is opposite. The next diagram here is just looking at forces acting on a projectile or something that's moving through the air. So this again is the same thing. It's being thrown up and then it's coming down. Whether it's going up or whether it's coming down, the force of gravity is always acting vertically downwards. That means it's causing it to accelerate vertically downwards, no matter if it's going up or if it's coming down. Okay, so that's an important concept. So the value for acceleration due to gravity is 9.8 meters per second. And what we have to remember is this acceleration is acting downwards. In yesterday's lesson, we did questions using kinematic equations for constant or uniform acceleration, and those were to do with things that were moving horizontally. So because gravity acts vertically down, it doesn't have a horizontal component, so gravity did not really affect horizontal motion. But for things moving vertically, gravity has an effect. Okay, so when we're solving problems, we can use the same kinematic equations, but we just remember the value of A, acceleration, is 9.8 meters per second squared. Now, some of the other things we have to keep in mind is that the time taken to reach maximum height, or the time taken to reach the top, is the same as the time it takes to fall back to the same level from which it was thrown. Okay, and then the other thing is what I've just said, the velocity is the same at any horizontal level, but it just acts in the opposite direction, whether it's coming up or going down, and we can use those 4 kinematic equations to solve problems. But however, because something could be moving up or it could be coming down, so we need to remember that these quantities of displacement, velocity, acceleration are all vectors. So in order to avoid mistakes, we use anything that's going upwards as positive and anything that's coming downwards as negative. So if you remember to do that, you should be fine. There are 2 questions on acceleration due to gravity with objects that are falling down or being thrown up. And I have worked out the answers, but before you look at the answers, have a go at it yourself and see how you go. All right, so bye for now.